Hi, in this lesson I want to talk about some kinds of geohazards that are caused by mining. In particular, in this first part of the lesson, I want to talk about instability, where ground becomes unstable because of mining activity. As you can see, I'm using a presentation that was given by the University of Leeds that I've adapted a little bit. There is a mining geohazards handout to accompany this presentation. So if you've got that, let's go. Now, if we look at some of the hazards associated with mining, we need to think about the strength of rock that's actually being excavated. Within that, of course, you've got any structures, any discontinuities or other weaknesses within the rock. And of course, as always, with any type of engineering activity in the ground, we've got to think about water. The interaction between these can be crucial. Now, it is possible to engineer solutions to these problems if they're known about in advance, if the geologists working with those are able to predict what's going to happen and to be able to put in place remediation measures. Okay. Let's start thinking first of all about subsidence, where the level of the ground sinks. Now, whether that's gradually or rapidly, it can be a distinct consequence of mining. And this is something that is an issue in all mining areas, for example in South Wales. Now this happens where there's space underground, where there's a void, and the weight of the overlying rock sinks into that void. If the roof or whatever supporting the mine can't hold that weight up, there can be sometimes quite a rapid collapse of that mine and a lowering then of the ground surface. Now, there are two types mentioned here on the PowerPoint slide. Macrovoids, which are big holes in the ground, or microvoids, which are small ones like pore space. Now, the small ones, the microvoids, can be an issue, for example, where fluid resources like oil is being extracted. The loss of pore water pressure will lead to the compaction of rock and subsidence. The same if we're extracting water on a large scale. However, if we're talking about mining, it's the macrovoids that are the big issue. Space is left in the rock where the valuable material has actually been extracted. So this could be in salt mines, for example, where we have either extraction of solid salt, creating underground rooms, or it could even be with a process we call brining, where either saline groundwater is pumped out the ground, or fresh water can be pumped in to dissolve the salt to pump out that saline water to extract that salt. But all sorts of other mining will create these macrovoids. Coal mining, metal mining, limestone mining, phosphate mining, all sorts of things will create these issues. In this presentation, we want to just look at the mining hazard. Now, an old-fashioned way of extracting usually sedimentary resources like coal or limestone was using a technique called pillar and stall. This is an example of an open cast coal mine that's dug down to a coal seam that has been mined historically. You can see that there are lumps of coal that are left. These are what the pillars. And there's space around there where the coal has been extracted. They're what we call the stalls, or sometimes they're called the rooms. The idea behind this was you dig out as much coal as you dared and left behind enough of the coal to act as a support for the roof of the mine. So the idea was that this void space would be left empty. Now, nature doesn't often work that way. These pillars can get eroded. If water table changes, the strength of them can vary. These are prone to subsidence. Here we can see another example. The dark areas are the coal that was left when this coal seam was exposed, and you can see just how little coal was left in place to support the roof. Now, these are often historical workings. The people responsible for this are often not around anymore. It can cause a lot of problems to people who own property above such old workings, and little redress if something does actually go wrong. A more modern technique is what we call longwall mining. This is where a shaft gets dug out through the coal seam, or two parallel shafts, and then the coal is stripped using this machine called a coal shearer. Strips out the coal between those two horizontal shafts, working back towards where the coal is actually taken out of the mine. Now, you'd think this would leave a big unsupported space, but what actually happens is the roof of the mine is lowered once the coal has been extracted. So you've got these large, you see them on the left here, these large jacks that support the roof of the mine that will slowly be lowered down to try and control the subsidence. So although subsidence will occur, it doesn't occur in this rapid, catastrophic way that can damage property. This type of mining still has the potential to cause some damage, but it's much, much less than the sort of very rapid, very quite large subsidence that occurs as a result of, say, pillar and stall collapsing. This is a cross-sectional view of this. So you've actually got the mining migrating to the right there, and the subsided area there to the left, where this gulf, where the coal has been extracted, that space is allowed to slowly sink. But you can see from your handout that we end up with a big bowl of subsidence, a large area, bigger than the mine, that will be affected by some degree of subsidence. It can have some quite surprising consequences. This is a pub in the Black Country in the Midlands, the Crooked House, for fairly obvious reasons. Strange old place. I don't think there's a right angle in the place. This has been affected by mining subsidence, and you can see the unequal effect of this, particularly in a pillar and stall type mining. So we see two different types here of subsidence. The longwall mining occurs fairly quickly, but it's a controlled way. The pillar and stall, or the room and pillar mining, was fine at the time, but we end up with a lot of historical problems caused by that. Perhaps often after mining in areas has been forgotten. There are also problems caused by instability of worked faces. We can see where we have an underground mine and rocks under pressure. You dig out the supporting rock around it, and we end up with rock bursts, explosions of rock into the mine. Really quite dangerous. Roof collapse in underground mines, any open faces in quarries or in open cast mines could collapse, or we see slope failure, mass movement slope failure. we've studied in some detail Aberfan as an example of that. Rock bursts then are uh, really very dangerous for the miners, and they're a particular issue in the very deep mines. You think about the gold and diamond mines in places like South Africa. Um, the amount of pressure that the rock's under there is immense. On the surface, though, they're not going to cause a great deal of problem, but it is something a mine engineer needs to consider. As is roof failure. Um, if you dig a hole underground, chance that some of the roof is possibly going to want to fall in. Uh, it is possible to use the slope stability techniques that we've studied, particularly like rock bolting, netting. You can see here, even shotcrete, to try and stabilize the top surface of a mine. But there's always a pressure then, of course, that that's not necessarily going to be a permanent fix. It may only be a temporary fix for while the mine is actually operating. Any engineered slope can fail if it's not engineered properly. There's all sorts of different types of failures. We have studied these when we're looking at mass movements. Quarries, open mines will always have a problem of rockfall from the top of faces. Various ways of dealing with this. Keeping the height of slopes fairly small, perhaps having benches. We can have making sure that the faces are cleaned of loose rock. Well, that can be difficult though, particularly near the ground surface where weathering might be more of an issue. Also, though, it might be possible to create like a sort of safe zone underneath the rock face where rock can fall, perhaps even with a rock berm, a mound of rock around the base of the rock face, just to catch anything that falls off, to keep people away from it. Very steep slopes can topple. If you've got a well-jointed rock, this can be an issue if you're extracting it. Remember, if you're extracting it, you're not necessarily going to want to bolt it in place and keep it back. This will be a temporary face but it is really important to engineer these slopes so they're less likely to do this. So we can see lots of different ways in which a slope will fail. This could be a slab failure if we've got dipping beds dipping into the mine or the quarry. Wedge failure here. There's joint planes, meaning that the rocks sort of are funneled in and collapse in a particular way. Very difficult to keep these in place. Rotational failure is more likely to happen in less consolidated sediments, where we'll see the bottom perhaps undermined, and then we get this rotational slip, like at Mamtor. Or it can all just go horribly wrong, like it did at this place called St Aidan's in Yorkshire, where an open cast mine sort of collapsed on itself, and you can see the canal on the left there that then drained catastrophically into the mine. So, there are lots of different issues with this. Some of these tend to be historical. If you look at your handout here, that for example, no one in the industrialised world extracts anything by the bell pit method anymore, because it's insanely dangerous. However, anytime you engineer a slope, whether that's digging out tunnels underground, whether that's creating new slopes at the surface has always got to consider the stability of those surfaces. Any mining operation, particularly any organised mining operation in the industrialised world, needs to have safety and safety of working faces as one of their probably their top priority. A mine that doesn't operate those safely not only faces extra cost and reputational damage, but also loss of production and loss of confidence from both its workforce and its neighbours. It's a key job for mining engineers, for geotechnical engineers, to maintain the safety of these working faces. And in a way, that's more challenging because it changes more rapidly than, say, stabilising rock or railway cuttings, which is going to be a far more permanent fix. Anyway, we'll wrap it up here. There are some other hazards we need to consider in terms of the geohazards created by mining, but we'll have that in another lesson. I'll see you then.